Hello everyone. Today we are going to learn about continuity of a function. Children, before starting with the questions of continuity of a function, let us define continuity of a function. In simple words or in day-to-day life words, I can define continuity of a function as if we are able to draw the graph of a given function without lifting our hand, then we can say that the given function is continuous. But if anywhere we have to lift our hand to continue or to draw the graph further, then it is discontinuous at that point. See, in this example, say this is my graph. If I want to draw this graph from this point, then without lifting my hand, I can reach to this point. So it is continuous at all points. See, in another example, if I have graph like this, if say I am drawing this graph from this point to this point, then up till this point this graph is continuous, but then to reach at this point I need to lift my hand to come here. That's why it is discontinuous at this point. So simply, if you are able to draw the graph of a function without lifting your hand, then it is continuous, and if you are not able to draw the graph without lifting your hand, then it is discontinuous. Now let's see how we can do the questions of continuity by the given example. Children, whenever we want to prove continuity of a function mathematically, then we need to see LHL, which is left hand limit, RHL, which is right hand limit, and the value of the function at the given point. Say the given point is C. If all of these comes out to be equal, then we can say function is continuous. That means to check the continuity at a given point, we need to find out left hand limit, we need to find out right hand limit, and we need to find out the value of the function at the given point. So here the given points are -1 and 1. Since it is given x is less or equal to -1, x is greater than -1, less than or equal to 1. So I need to check the continuity at x equal to -1 and yes at x equal to 1 also. So let's see how we can perform the solution. So this is the condition of the continuity. So if I want to check the continuity at x equal to -1, then first of all I will be checking my left hand limit. Now whenever I am doing my left hand limit, that means we need to take the value slightly less than this -1, and we write it like this: limit x tends to -1, and then we put a minus sign above, which shows that we will be taking the value less than -1. First of all, we need to select the function out of these. That means if I am taking x is less than -1, x is less than -1, then the function for this will be -2. So this will just give me -2 because it doesn't contain x. I need not to put x equal to -1 anywhere. So your LHL is -2. Let's see for RHL. Children, when you are writing RHL, then you will be writing limit x tends to -1 plus. That means you are going slightly more than -1. So if it is more than -1, here it is given x is more than -1. So the function defined here is 2x. That means, children, whenever you are taking this thing, if I am changing the value slightly more than -1, then I will be writing it like this: h tends to 0, and say this x is what? -1. So I am increasing h value in this. So here h tends to 0. Whenever the function is given in h, then limit should always be in h. So I can write it here. I can put the limit. So this will be just -2. Now I have to check the value for the function. So I will be checking for the function limit when x approaches to -1, then the function is, that means x should be -1. So x equal to minus 1. Here this is x is less or equal to minus 1. So the function again here is minus 2, and which gives me this. I can write function value as minus 2. Now children, you can see here LHL equal to RHL equal to your function at f equal to minus 1. All of them are equal, so I can say therefore function is continuous at x equal to minus 1. Similarly, we need to check the continuity at x equal to 1. You have a look, then we'll do for x equal to 1. Now children, let's do it for x at x equal to 1. Now fx is equal to, if I am taking at x equal to 1, so say I am taking at x equal to 1. So this is the value, this will be the function when I am taking x equal to 1. So my function here will be limit x tends to 1 and my function is twice of x. So this can be written as 2 into 1, which is equal to 2. Now for LHL, I will be writing my function as limit x tends to 1 minus, that means slightly less than 1. So you need to first find the function for it. So this is x is less than 1. So which is x is less than 1? This is x is less than or equal to 1. So again for this I will be taking 2x. But since I am taking x as slightly less than 1, that means I have to write it as x tends to 0 to this x is the given value 1, and I am doing it for LHL, so it should be written as 1 minus h. Now putting the limit here, it will be 2 1 minus 0, which is equal to 2. Now you see it for right hand limit, this should be limit x tends to 1 plus. So my function will be 1 plus means greater than 1, slightly greater than 1. So this is x is greater than 1. Therefore the function defined over here is 2. So here I don't have x, so this limit will not be put here and it will be simply 2. Now you see here my function is having value 2, LHL is coming out to be 2 and RHL is also coming out to be 2. That means my function at x equal to 1 is equal to LHL is equal to RHL. Therefore function is continuous at x equal to 1. Children, by 1 minus and 1 plus, what do I mean? Children, if we have a number line 0, say this is 1, that means if I am taking LHL left hand limit, that means I am moving slightly towards my left. That means I am going slightly less than value 1. That's why I am writing it as LHL. And if I am making it for RHL, that means I am moving slightly more than 1, greater than 1. That's why I have written this here 1 plus and 1 minus. Let's see one more example, children, here. Look children, in this question we have to check the continuity at x equal to pi by 2. And this question is your board question also. This has come many a time in board papers. Let's see how we can do this question. First of all, we'll find at x equal to pi by 2. So for the function, we can write limit x tends to pi by 2. At x equal to pi by 2, the function is 3. So simply this is 3. Now let's see it for left hand limit. Now here the function defined will be, I'll be writing it as limit. So for LHL, I'll be writing it x tends to pi by 2 minus, that means less than pi by 2. And here the function will be, this is for x equal to pi by 2 and this is for greater than pi by 2 and for less than pi by 2. So the function here is k cos x upon pi minus 2x. Now children, when I am taking it as pi by 2 minus, that means I have to replace my x with pi by 2 minus h. Why I am doing minus h? Because it is slightly less than pi by 2. So here this can be written as limit h tends to 0 k cos x will be pi by 2 minus h whole upon pi minus 2, and this x will be replaced with pi by 2 minus h. Children, just now I told you whenever your function is in h, you need to write limit in h only. When your function is in x, you need to write your limit as x. Now this can be written as cos pi by 2 minus theta will be your sine h whole upon, this will be pi minus, I am multiplying 2 inside, so it will just be pi and then plus 2h. Pi and pi gone, so I am getting it as k by 2 sine h by h. And yes, don't forget this limit. Limit h tends to 0, and here also it is limit h tends to 0. So this sine h by h with limit h tends to 0 is one that we have read in class 11. So this will give me just 1, and I will be left with k by 2. Now you see, for RHL it should be limit x tends to pi by 2 slightly more than pi by 2. So here again your function will be this k cos x upon pi minus 2x. But when I am writing limit in h tends to 0, then this will be k cos pi by 2 plus h whole upon pi minus 2 pi by 2 plus h. Now children, I know cos 90 plus h will again be sine h of cos k, and of course limit h tends to 0 whole upon, I am multiplying this 2 inside, so it will be pi minus 2h. This and this will go away. So this is limit h tends to 0 k sine h by, this is minus 2h. Now again I can say limit h tends to 0 sine h by h is your 1. So here I am getting it as minus k by 2. Children, now this is continuous. This function can be continuous only if LHL equal to RHL equal to the function at x equal to pi by 2. So I can just write my values here. So my LHL is given as k by 2, and my RHL is minus k by 2, and my pi by 2 is your just 3. So I can compare the value here and I can find out the value of k. Children, here it is cos pi by 2 plus h will be sine h, and the sine will be minus because this goes in second quadrant. In second quadrant cos is negative. So this minus and minus will get cancelled, and here will be getting plus k by 2. So I can compare either this with this, or I can compare this with this. So here if I am comparing any of these two, then I am getting k by 2 equal to 3. That means k equal to 6. If k is 6, then this value, this function will be continuous at x equal to pi by 2. Have a look.